Okay, so welcome again in this first day of 2020 IPROMO course. And I welcome Rodika Nitu from Global Cryosphere Watch, World Meteorological Organization, and she will give us a lecture concerning understanding climate change in the mountains. Okay, please, Rodika.
Good afternoon, good morning, and excuse me, good evening to everyone. And thank you for the invitation to present in the opening session of this course. I want to thank all our organizers, and in particular, I want to thank Rosa Laura Romeo for the kind invitation and for spearheading the collaboration between Mountain Partnership and the World Meteorological Organization, and in particular the Global Cryosphere Watch in the last few years, which I think would be for the benefit of both our communities. So I would just like to introduce myself. So as mentioned, I'm from the World Meteorological Organization Secretariat in Geneva. I'm responsible for a program that focuses on improving the understanding and the sharing, the collection and the sharing of information on cryosphere. And the focus is on polar regions and high mountain regions, and with this to support communities like the Mountain Partnership to better understand the changes and to prepare for addressing those changes through appropriate action. So in my presentation today, I'm going to give you a short introduction on WMO, as well as talk about climate change in the mountains more in general terms, but also taking a more practical view. And in that context, I would be touching on two aspects that are very much near and dear to my heart, and these are related to how we use data to understand climate and how we support the observations that are required to produce the data to ensure that there is a strong foundation for understanding climate change and for understanding the actions that are required. I will also talk at the end of the presentation on some of the next steps that are considered in the context of the activities of WMO to better support the mountain communities. In terms of the interaction throughout the next 2 hours, I understand that the structure is to have questions in the latter 15 minutes of each hour of the presentation. But if there is a specific question, because the topics will be changing throughout the presentation, I don't mind to be interrupted, provided that we don't, or at least to note some of the topics that are being raised and to be able to return or to emphasize some of the information that is being presented and is of interest to the audience. And I would invite, as Danilo said, the chat is monitored, so please feel free to use it for asking questions. And I'm going to say, like, sometime early in my career, I actually taught, and I would say, well, please pay attention. There are going to be 3 questions. from the material presented here, and I wish everyone will get them right. So with that, a few words about the World Meteorological Organization, which is a UN specialized agency, is an intergovernmental body, which really means that the membership of the 193 members is established at government level, and that the decisions and the resolutions of the agency are legally binding in the international context. So the role of WMO is to facilitate collaboration and cooperation at the global level on monitoring and predicting changes in weather, climate, water, and other environmental conditions. And this includes cryosphere, it includes atmospheric composition. And this is achieved through ongoing exchange of data, information, and services. So you may see the trend that I'm going to repeat throughout the presentation. It's really about the regular, sustained, continuous type of observations, data exchange, and services, which provide the foundation to better understanding the changes over time at different scales with respect to climate. Standardization and the support to ongoing research and scientific understanding of those changes, as well as capacity building, especially in developing countries, are at the forefront of the activities in WMO. One could say that is about transferring the understanding and the knowledge from developed countries to developing countries, such that the methodologies, the tools, for exchanging the data and information are utilized at the global level as successfully as possible. I'm actually going to change to the laser pointer. Okay, did it. Here on the, so at the top left, you can see the headquarters in Geneva. And at the bottom on the left is the constellation of observing systems on land, on the ocean, and in space. And this together form the integrated observing system that supports the understanding of changes in the climate, supports weather forecasting, and all other services related to environment in a continuous and sustained way. So, see how I manage, just a second, a small technical, okay. So the mountain and the cryosphere. What differentiates mountains from the rest of the globe is the presence of snow and ice. And interestingly enough, you could see that of the water present in the Earth system, only a very small percentage is fresh water, but of that, 3%, 2/3 is actually stored in ice caps and glaciers. It doesn't want us on. I apologize. Once changing to the pointer, it actually the mouse, I can't change the slides with the mouse. So sorry, small technical detail. So a cryosphere comes from the Greek word cryos, which means ice cold. The forms, the components of the cryosphere that we know, and snow, glaciers, ice sheets, ice shelves, sea ice, lake ice, river ice, permafrost, and seasonally frozen ground. But in the mountain communities, snow, glaciers, permafrost, and seasonally frozen ground, as well as lake ice and river ice, are features that you are the most familiar with. These are present in different forms in nearly 100 countries, and it's an important resource, whether it's for water resources, supporting agriculture, and with it, food security, whether it's for energy production or important with respect to the development of infrastructure. And for ecosystems, and with a significant impact on weather patterns. Cryosphere, as I mentioned earlier, is an important element of mountain environments. It is also the most sensitive indicator of climate change. And whether we talk about glacier melt, permafrost thawing, changing in snowfall pattern, like the rising snow line, these are very clear indicators that you are experiencing, and monitoring them would give a very good indication of changes in the climate, not only at local scale in your communities, but also at global scale. So what is the value of mountain cryosphere? And I tried to summarize here in a table, and you could see, that there are a lot of words, and I think every one of them describes a different dimension and a value of cryosphere in the life of communities, mountain communities, but not only. This contributions from mountain cryosphere are felt downstream, being carried downstream by the rivers that have the headwaters in the mountains. So some of those aspects are related to water supply. As I mentioned earlier, whether it's glacier, snow, permafrost, or glacier lakes, the contribution to irrigation, water for domestic use, hydropower, the support for agriculture, for livestock, as well as all activities related to irrigation and domestic use. The water is a significant contributor to the well-being and to ensuring the sustenance of communities. From a socio-cultural perspective, tourism, religion, sports, and the aesthetic value are important components. And again, whether it's glacier, snow, or glacier lakes. From a climate and water resources perspective, cryosphere has a regulating value. And from a habitat perspective, whether we talk about flora, fauna, microorganisms that are living in glaciers or in permafrost, or those in glacier lakes, but it's also a factor of risk. And significant hazards are known as a result of changes in the cryosphere and the changes in glaciers leading to ice and rock avalanches, to the loss of water resources, and that leading to droughts in the long run. Snow avalanches and snowstorms, the degradation of permafrost and seasonal frozen ground, although over a longer period, are leading to changes that are irreversible and do have impacts, whether it's on the infrastructure, the sediment flow, the slope instability leading to landslides, rock avalanches, and one that is quite important in the global level, the increase of greenhouse gas emissions. Of course, the glacier lakes are one of the most important factors of risk, the most important hazards that you are facing, and leading to glacier lake outburst floods. And at the same time, with the outburst floods from glacier lakes, what is lost is the ability to naturally store water at high elevation. Sorry. So yes, it doesn't matter whether we are talking about mountains in Europe, in Asia, in South America or North America, or any other place with mountains on Earth. The nuances are different, but fundamentally the issues are the same. And here I have an example from the team we are working with in Chile and Argentina. And in essence, the snow that accumulates each winter in the Andes represents a crucial water resource for sustaining human consumption of water, the agriculture, the hydroelectric generation, and the industrial activities in the lowlands. So a number of years ago, about 15 years ago, there was an international polar year. And at the time, the focus switched, the focus increased significantly on changes in the polar regions. And at the time, those involved coined the statement, what happens in the Arctic doesn't stay in the Arctic. And it's absolutely fair to say that what happens in the mountains doesn't stay in the mountains. And it's important to be able to, through communities like this, through US ambassadors from mountain communities from different countries, to actually sustain the message to the lowland communities that their livelihoods depend very much to what happens at the higher elevation. So just to put things in perspective, I would like to remind you one of the summary tables that was presented in the recently published IPCC report on the ocean and cryosphere and the changing climate, SROC, which was published in 2019, and which includes a chapter 2 on high mountains. And among this particular chapter, but the entire report has become the most important reference to understanding what we know and what we actually don't know with respect to climate change and its impacts in the mountains. And the reasons why we don't have the full complement of information necessary to understand those changes. And from my perspective, this table, which summarizes the observed physical changes and impacts in high mountain regions over the past decades, that can be, at least in part, be attributed to changes in the cryosphere. Presents all the attributions to cryosphere change, whether it's in terms of physical changes, the ecosystem changes, and human systems and ecosystem services. What is actually very interesting in this table is what is missing. As you can see, and representing different countries from all over the world, I'm sure that you can find in this table your region, whether you come from Southern Andes or from the low latitudes that include basically tropical Andes in Mexico, as well as the mountain regions in Eastern Africa and Indonesia, or in the Caucasus. You can see that many cells in this table have been left blank, which means that no assessments have been conducted, as you can see in the legend. And no assessment means that they are not applicable, and it's for you to judge whether or not it's applicable for your region, not assessed at regional scale, or the evidence is insufficient for assessment. So, for example, if I was to look at landslides, whether in low latitudes, in Southern Andes, in the Caucasus, there are no such assessments. Where assessments have been conducted, you can see that the attribution confidence varies from high to low, and many of assessments conducted, again, if I look at landslides, have a low attribution confidence, which likely has to do with the fact that no sufficient evidence was available for the assessment. And this, when looking at this table overall, it is quite clear that many areas, many mountainous areas around the world are suffering from a lack of systematic information that would better equip the communities to support the request for improved services, the request for changes in how services and decisions are being taken at regional, provincial, local level. And when competing at national level with many other interests, the lack of information becomes a significant drawback. And I hope that with the information that you gather through courses like this, and with support from Mountain Partnership, you could address the information gap, which becomes the most important tool in supporting the need for adjusting to the changing environments and the changing climate. Another aspect that I want to bring to your attention from the same report, it has to do with access to water. As I mentioned earlier, water is an essential resource, both for mountain communities, but in lowlands as well. And the melting of glaciers have changed the annual runoff, but with a wasting of glaciers, the melting of glaciers completely, this abundance of water would likely disappear. So the science coined the term peak water, which refers to the year when annual runoff from the initially glacier-covered area will start to decrease due to glacier shrinkage, and this coming after a period of melt that induced an increase in water available. So the IPCC report published last year has a very interesting map, graph, and mapping by region. The peak water, the year when the annual runoff will start to decrease, in two different emission scenarios, one for RPC 2.6, the other one RCP 8.5. As you could see, so here we are in year 2020, and in some regions, like Western Canada, Central Europe, and Caucasus, as well as low latitudes, this peak water has passed. Whether it's on RCP 2.6 or RCP 8.5. In other regions, as North Asia or high mountain Asia, or Southern Andes, the peak water is yet to come, but in not so distant future. I think it's quite clear that from this graph that the time when the regions everywhere around the world will start experiencing significant diminishing of water available is not so distant in the future. And this is an important piece of information that needs to be taken into account for planning in the long run. The organization at regional and national level that would develop feasible adaptation strategies, whether having to do with water management, whether having to do with adapting to different crops being grown that are more resilient to drought. But the planning and the transition takes time, and it's important to understand now the changes that are coming to be able to prepare and build the resilience in the society. In that sense, the overall understanding of changes are important. Understanding that there is both harm and there are also benefits, albeit being a short-term benefits that need to be emphasized and need to be well understood to have agile enough societies to be able to adapt. And for that reason, having access to data and information becomes critical, because this is the only way to support understanding the risk, whether we are talking about floods, drought, avalanches, landslides. So understanding the exposure, understanding the vulnerability. For the same measure, it's actually important to understand what are the benefits and harvesting the benefits from the information available, which really could mean when and what to plant and when to harvest, how to manage water resources, where, and the timing of runoff, and also planning and understanding the impact on transportation, on infrastructure. So every element of the society that actually is exposed to the changes in the environment could be looked at both from a risk, a vulnerability, as well as a potential for harvesting certain benefits. And the Sustainable Development Goals provide some of the framework that, to which to link and assess both the risks and the benefits. In this context, actually, WMO and in cooperation with the national meteorological, hydrological services and all other institutions that are actively involved in the development of sustainable services in the framework of WMO, plays an active role because it has the ability to take the multifaceted approach to understanding the gaps and to developing the tools that would help better reaching the goals related to the Sustainable Development Goals, but actually translating into indicators and measures that could regularly better characterize the changes in the environment and providing the information available. So, because I mentioned about the role that WMO could play, I have here a diagram that probably looks a bit too busy, but I'm going to try to provide some understanding of it. So this is actually a diagram that shows the service chain from observations to prediction and to services delivered to users, whether we talk about water managers, farmers, emergency response managers, policy decisions, whether it's funding and development agencies, as well as the research and innovation community. But in order to support the needs of the diverse communities, a series of activities need to take place. And they start from observations. Data from observations are essential input to the development of information that supports users. This is together with experiments, process description, other inputs from other sciences, whether it's socioeconomic sciences, together become part of the input into models that integrate and process data to develop integrated information for downstream services. There is an increased need for better understanding the user needs and taking into account outputs from science, other sciences like socioeconomics, to actually be able to translate the needs of communities into information that actually is relevant to the specific users. One of the challenges that it's been reported quite often from many countries is the disconnect between the services, the operational services that provide weather information, that provide climate information, and the ability to transmit the information in such a way that is understood and acted upon by the user community. We had recently a series of meetings with representatives of our members, and in particular, the representative from Peru raised his concern that the services in, for example, early warning information, when the information needs to be very clear, transmitted in basically real time, because it needs to be acted upon. For example, floods. But the ability to convey the information in such a way that it's understood and action is taken, it's really something that there is a lot more to be learned. And as you can see, the diagram here is one-sided in a way. The communities that I represent have some work to do to better understand the perspective of users, to factor that perspective in as an input to the development of services and tailor those services to the community to which those services are intended to be delivered to. And this is part of the ongoing fine-tuning of services. And it's important to hear the users and how they utilize the information. Now, because from the next slides, I'm actually going to change the topic somehow. Sorry? Hello?
Sorry, someone?
Yes, I just wanted to ask whether there are any questions, because I'm moving on. I'm changing a bit to somewhat a different topic related, but different. Is it now a good time to ask if there are any questions?
Okay, if we can allow, let's say, 3 questions.
Okay.
3 short questions, or otherwise one. that go in deep. So please use the chat and I'll submit to the lecturer.
I see that there is a question on if it to enlarge the presentation.
Oh yeah, because it's we see your slide, but also the tools that PowerPoint shows you.
Okay, so
when
I'm
you're
not
presenting.
sure what I'm supposed to do on that.
I guess the fourth icon, I guess, but I'm not sure. Yes, that one. No, not
Black or
you
unblack
can
switch.
move to the left. Sorry, just to see your slide now and
No, that's on
the
slide
lens.
zoom.
But I'm not sure that.
No,
Okay, no, absolutely.
No, because I have, I mean, I have two screens and my full screen is a full screen. So I'm not really sure what I can do. I'd love to be able to, but I don't know.
I think you should just swap the presentation on the screens, on the two screens.
But I don't know how to do it. That's the problem. Show taskbar.
Maybe display settings. It could be the where you can find this.
So you are because normally you should. Let me then stop sharing, and I'm going to share it differently. Share.
Danilo, I think there is also a question then. I think.
Yes, but I would like to wait for.
Yeah, I think
okay, perfect.
It was better, Radhika. Now it's a little bit larger.
Okay.
Okay.
Yeah,
okay.
it's better. Yeah, and there are also at least one question. No, Danilo, maybe you can.
So it's here. Please kindly elaborate more on data infrastructure for prediction within undeveloped economies.
I will like to reserve that answer once I go through the next few slides. I hope I can answer to the satisfaction of the person asking, but yes.
Okay. And there is another one. When you use natural capital and service concepts, what kind of theoretical framework are you using?
Let me just a second. Oh, sorry. You are talking here.
Yes.
Yes. I must admit that I wasn't really looking from a theoretical point of view, but it's actually the natural capital of the region or of the country, so the natural capital of entity or the geographic area that is considered at one point or another, not necessarily in. I would say in more less theoretical way, but rather the natural environment as a whole. Not sure if this answers your question.
Thank you. It's okay. Thank you.
Okay.
Okay, I think that we can go on. Or
yeah.
if there...
No. Yeah. So with that, I'm going to go in the next few slides on focusing on observations. As I mentioned at the beginning of my talk, the foundation for understanding actually comes from the ability to observe and have the data necessary to better express and depending on the application, use for modeling the changes and projecting the changes, understanding the changes in the past and projecting the changes in the future. But this is not as simple as running observations at the quality required to understand climate change is actually a very resource-intensive activity and require long-term commitment. And the continuity of observations over the long term is one of the most important elements to understanding climate change and to understanding changes in the environment, whichever those changes may be. So having physically observations on weather, climate, water, cryosphere, requires a commitment, a long-term commitment. One are the physical observations in the field and whether they are done more traditionally by people, by human observers, or using automatic weather stations. The ability to have data available and archived and quality controlled for the long term is important. It requires well-established protocols and well-established data centers. One area that I haven't put it explicitly on slides, but it's actually important to differentiate is that and especially in the mountains more than in lowlands, there are a number of, a multitude of scientific studies, and their value increases with increase in the longevity of those studies. And this is where, as a foundation and general at the national level, there are observing, often quite simple observing stations, observing programs run by generally meteorological services, national meteorological services that provide the minimum of data required to monitor and report on changes. In mountainous areas, and in particular with respect to cryosphere, there are a multitude of players, and the interoperability of data systems from which to be used in an integrated fashion to support prediction, for example, is still a goal. And in the absence of being able to integrate data from a multitude of sources, especially in countries where observations are sparse, is critical to ensuring the observation-based observations and data foundation to support prediction systems. And this is very much a challenge for developing countries. The sustainability of observing and data systems over the long term is also a significant challenge, but without continuity, interoperability of data systems, and sustainability of observations and of data including data archive, it's actually difficult to make well-informed predictions and to have well-informed assessments of changes, especially when we talk about changes at smaller geographical scale. So this is a bit of a busy map, and it's really here as an example to show that this is about snow observations from satellites. The fact that the same snow observations are required for different applications, whether we talk about water resource management, where the observations, the data is required at a great spatial resolution, and at a daily temporal resolution, going into numerical weather prediction with a spatial resolution at about 5 kilometers, but the same sub-daily temporal resolution, going into climate analysis, climate models or seasonal forecasting, where both the spatial resolution and the temporal resolution go into the hundreds of kilometers, and the monthly spatial resolution. But in the end, the investment and the ability of providing data with different satellite systems is still, as you can see, it's still not there at the level where this would ensure a reliable source of data at a larger scale and continuously. So when it comes to mountain regions and to a large degree polar regions is somewhat the same situation. The ability to, the desire and the goal of bringing together ground-based observations with satellite observations is there. There is still work to be done in being able to bring the different sources of data, providing reliable, for example, snowmelt information, such that on a continuous basis, the various applications, whether it's water resource management, numerical or prediction, and understanding the processes would be supported with sufficient information from space missions to meet the needs. So there is a lot more work that needs to happen in that sense, but the diversity of applications only adds to that challenge. So there's a bit of theory. And you know the saying that climate is what we expect, but what we get on a daily basis is actually weather. But in the end, in order to understand climate, we need to look at the information we have at over longer periods. So there are two terms that I want to introduce to you here today. And one is the climatological normals, which are basically the various averages over different intervals that constitute reference against which conditions, whether current or recent, can be assessed. They are actually used as indicators of conditions to be experienced in a given location. But what is more important than that are actually the climatological standard normals, which are averages of climatological data computed for well-specified 30-year periods. And those periods are 1st of January of the years 1981 to 31st December 2010, and the most recent is January 1st. No, I'm sorry, it should have been December 2010. January 1st, 1991 to December 31st, 2010. And the period 1961 to 1990 is the standard reference period for long-term climate change assessments. So when we hear references about changes in the climate, having a well-defined and internationally recognized reference to which to refer all the studies that are being conducted at different scales becomes very important, because then different groups, different institutions, different assessments could be in the end collated together because they use the same reference. I used here just to show that I've actually used the Swiss Federal Office of Meteorology and Climatology website just to show an example that, in fact, every meteorological service has the responsibility at national level to collect, curate, and make available in one form or another the normal values for each of the stations that are being considered as part of the reference climate stations that provide the data to be used for the climate normals. One important element is that in order to derive the climatological normals for a station, that station has to be in operation continuously for the 30-year period for which the record is derived. And it has to have reliable observations in terms of the method of measurement, in terms of understanding aspects related to the operation of stations, whether it's maintenance, upgrades, and so on. Everything that could be tracked, explaining any discrepancies in the data sets, such that the reference that is being created at national level becomes, so first of all, it's sound, but it becomes a real reference to which all other studies would refer. As you can see here, there are different parameters, and the range of parameters and how to calculate the climatological normals are well defined through methodologies and resolutions of WMO, such that there is a systematic approach at global level. The range of data and how these are presented by each national meteorological service may differ. In some cases, you can download, whether it's PDF, a text by station. So the format accessing differs, but the content would be the same regardless the country, all having the responsibility to make this data available to the public. And the range of data collected is quite extensive. So I just wanted to mention, for example, for temperature, it's not only the value of temperature, values like monthly means, daily maximum and minimum, as well as different other intervals. For example, number of days with sunshine, number of days with cloud cover, number of days with temperatures over various intervals are being made available through this interfaces. What I actually should say that this information is not only necessary for further science studies. This information is actually quite important for any applications, including better understanding the changes in temperature, precipitation, and other parameters that will be needed to adjust, for example, the practices related to crops, to identifying the start of the season, the end of the season, and so on. So it's both a support for science, but a support for communities at large. And the next two slides, I'm going to go through an example of the report generated by the Department of Hydrology and Meteorology of Nepal on observed climate trends of Nepal over the period 1971 to 2014, a report that was published and is available on the department's website, and so was published in 2017. It's a quite comprehensive report, is looking at each of the standard variables that are included in as part of the portfolio of climate normals. And here I actually focus on the winter maximum temperature trend by district. And this is where this analysis become important, because they move from the general national level or regional level to more at the district level. So it becomes much more representative and meaningful to the communities on the ground. And you can see here over the period of analysis how in most areas there's been a change in temperature towards positive change in the winter maximum temperature, and this appears to be most important in the Himalaya region. The seasonal and annual maximum temperature time series over the same period is provided. But as I said, many other views on the changes in the climate of Nepal are presented in this report, which is a typical report that Department of Meteorology or the equivalent in every country would make available for its population. So this is the... Hello?
Excuse me, there is a question.
Yes.
And and there is a question and an announcement. First of all, from now, just to be more natural, just write in the chat that you want to make a question, and then I give you the word, and you can talk. So it's better and easier for communication. This is the last one I'll read. The next one, the student can only write that he wants to make the questions, and I'll give you the word. So the question is, are climatological normals the indicators of change or sort of a threshold that turns yellow and red lights of acceptability of change?
I guess the answer is formally no. I guess it will depend very much on the context in which the information is used. It would probably, because we are talking about change that has been observed, not projected change. So I'm hesitant to say much because it's actually I guess using this thresholds in some definitive way would be quite difficult depending on the context, but definitely should alert the decision makers, because in the end, this information is as valuable as one uses it to act, to address the change. So it's really how the information is actually used in the context, in the national context, in the local context for action. The responsibility is to report, and then users to take this and turn it into arguments for supporting specific action. So I guess with what I'm going to say now, it would actually, I'm looking here at the previous question on elaborating more on data infrastructure for predictions within developing countries, I guess. And I would like to point out one interesting fact, and see why I was quite reluctant to answer definitively the previous question. So as I mentioned, for the climatological standard normals, there is a requirement that a 30-year continuous data set is available from a station. Also has to have continuity of observations at the same location over the study period in order to determine and in the end understand, report on the climate trends. Which really, if you think that the most recent period is 1990 to 2010, it actually, and this map here highlights the challenge. In reality, the number of stations at national level is quite reduced. Because, as I was saying earlier, it takes a significant investment to maintain over a 30-year period observing systems in pristine conditions and with a sustained maintenance and all the aspects related to support, data archival, and so on, such that in the end, the record is available. So in Nepal, for the period 1971 to 2014, there were 93 stations used for this study. What is actually interesting is that the study recognizes that in the high Himalayas, they only had 2 stations. And they had a limited number of stations in the high mountains. So while there are quite, and I put the 2 maps together, as you can see, the winter maximum temperature trends and so on are actually reported at district level. You can see that the information available to draw these conclusions was rather limited. So understanding the scarcity of observations over the long term is one part of the story, but actually doing something about it, it's the other side of the story. And this is where my other my reservation about the answering the last question. The ability to have definitive answers is supported by the ability to have access to information that would support with direct observations, not extrapolation, the conclusion drawn. And the ability to act depends on it as well. So while at the international level, there are numerous institutions and numerous initiatives, whether through the Climate Fund, whether supported through the World Bank and others, to enhance the observing networks and the data capabilities of countries to address the scarcity of observations. Mountain regions are probably less represented in the from the perspective of the full complement of needs, as opposed to the lower elevations. So when I opted to talk about this aspect, really, I was thinking of the need to emphasize the need to address the observations gap with communities like those around the virtual table of this course, who are users of information, but understanding where the information is not at the level that is required, it becomes an argument to support addressing the observations gaps, because by addressing those will actually help addressing the knowledge gap regarding the changes in the environment. Yeah, I guess that's so. Again, I just want to stress out that is the continuity of observation at the same location that becomes very important. And the reference that I made earlier about the longevity of scientific studies, it really comes, it's related to this point, that scientific studies are an important contribution to the wealth of information available in the mountain regions in this case. But having their support over the long term is essential to complement the observing networks of the various government agencies and to support the full understanding of changes in the mountain climate. Okay. So, in the WMO context, most meteorological, national meteorological services are registering their observations in a database maintained by WMO, which is called the Observing System Capability Analysis and Review Tool, or OSCAR. And this gives a global view of which stations, which observations by parameter are available where. And this is important in the context of global models that are being run, for example, numerical weather prediction, climate models, and so on. So here is a summary on where the observations are, as you can see, and this tracks at this time just observations from the meteorological services. So as you can see, there are basically 10,000 stations at less than 500 meters. There are another 2,000 stations and somewhere between 500 and 1,000 meters elevation. There are 770 stations at 1,000 to 1,500 stations. So half of that for 1,500 to 2,000 meters, and 132 stations registered between 2,000 and 2,500, 62 stations registered as providing continuously observations over 2,500 meters to 3,000, and 36 stations to 3,500 meters, and only 17 stations above 3,500 meters. Well, we were talking about Nepal. Here is Pyramid Lake at 5,000 meters, but as you can see, a handful of stations at higher elevation. Now, if we think that changes in snow and especially ice, glaciers, and the frozen ground at high elevation are significant sources of risk and changes for the mountain communities, the lack of understanding of what's happening at that elevation and tracking it over the long term is a significant gap that that prevents the gathering the right information to support arguments, to support changes. So yes, this is a different way to look at the number of stations available. Now, this is just the same idea, looking at it at a smaller, at the continental level in South America. And again, the most of stations are at low elevation or away from mountains, and this is why there continues to be a limited understanding of many glaciological and hydrometeorological processes and interactions, especially when we talk at smaller scale. We talk watersheds and specific river basins and specific valleys. That remains a significant challenge. So again, just in summary, I talked about observations, but all these observations become data, and this data is useful provided that there is a good understanding whether it's configuration, observing practices, and most importantly, is the data that I have access to the data that I need. And I will actually come back later on at a question on services concept, because I had the chance to see the question and actually probably reflect a bit on it. But the ability to, if one would look at providing this data as a service, it's one aspect how the national meteorological or climate services provide to at national level to their citizens, because the curating of data and explaining, providing the information on data to make it useful for the application is one of the services that increasingly these institutions provide. So just an overview, meteorological and climatological observations. Most observations available cover temperature and precipitation, and from a climate standard normals, temperature and precipitation are the two critical parameters. When we talk about precipitation, it's unfortunately mostly focusing on rainfall. So whether it's talking about intensity or accumulated amounts over given periods. So unfortunately, the ability to monitor and report accurately on precipitation when it falls as snow is still a challenge. And excuse me. And in that respect, some of the data available for mountain regions is usually lacking. Also, wind speed, direction, atmospheric pressure, humidity, solar radiation, and the depth of snow on the ground are typical observations that are available from most stations. Again, whether it's a station where a human observer reads the instruments and reports the reading either manually or more recently via the internet, or using automatic instruments in all conditions, including at high elevation, and transmitting the data either after the fact or, if possible, in real time. As I mentioned earlier, the space-based observations are a significant contributor to the models run for forecasting and prediction. But when looking back to assess changes and trends, the primary source remained the in situ observations. When it comes to high elevation, the observations in these conditions present numerous challenges. The high cost to install and operate, especially over the long term, make the expansion of such networks rather difficult. The ability to access these stations again contribute to or prevent actually the installation of stations, even if the hardware itself is relatively inexpensive. And I've seen over time projects where the reduced cost of equipment was seen as something like here, weather station on a tripod was seen as a good argument to buy lots of weather stations. The reality of being able to install and operate those stations in difficult, especially mountain conditions, led to purchasing the equipment and never deploying it. So when talking about the data infrastructure for prediction, so the different projects that take in that focus on strengthening the observations and data infrastructure need to be well scrutinized by recipients. In every country nowadays, there are very good scientists and engineers who fully understand the full chain required to actually have data available from installation and maintenance and so on. And I think it's the responsibility, and I encourage everybody to scrutinize those proposals that do not take well into account the difficulty of maintaining observations at high elevation, and to settle for fewer observations but of high quality rather than the other way around. Yes, the ability to power and transmit the data that is increasingly being addressed by the newer technologies, but it remains a challenge. The remoteness and also the capacity in terms of expertise and people willing to go and install stations in these conditions are all challenges. But the reason I wanted to have this slide is, again, that I encourage everybody to actually pursue projects where which would lead to enhancing the observing capacity and the data transmission and the data storage and data archival, but take a full chain approach and scrutinize the proposals to ensure that what is obtained is meeting the end goal, and it provides the good quality over the long term. So this is just an example that when it comes to cryosphere monitoring, especially at high elevation, the observing techniques are quite different. And this is an example of snow water equivalent. So to assess the water stored in snow at high elevation, And aside from very expensive equipment, this is still a manual method. The monitoring of changes in the permafrost and the frozen rock is also an area where observations are very scarce. And as you can see, the installation is not for the faint of heart. So the techniques are very specific and quite challenging. Here is an example for a glacier mass balance measurement where, and I'm actually going, for the interest of time, going through all elements. So the monitoring of glacier mass balance, basically, which will provide the overall mass, and with it water storage in the glacier. It requires a series of observations which will look at changes in accumulation and ablation of snow and ice, some hydrological stations, rain gauges, automatic weather stations, and regular snow pits for snow density, ice, and thickness. And I have this slide because I was asked this not long, a few months ago, to provide a state-of-the-art automatic weather station to monitor changes in glaciers. And I had to explain that it's not as simple, and there is actually a lot of, and the full understanding comes with a significant investment of time and effort from one or more experts who will actually do the measurement on site once a year, once several years. So again, it's a bit of buyer beware, I guess, but it's important to understand that all this information that is required for mountain communities comes with a significant investment and complexity of work. This is an example, it's a slide that I have from Colombia, from the Meteorological and Hydrological Service. And this is a graph that shows the change in glacier area for Sierra Nevada, El Cocuy. And I have this slide only to show that over the course of 40 years, there have been, as you can see here, 7 full glacier mass balance and glacier area assessments, owing to the fact that these are intensive and expensive expeditions. But definitely a very good correlation between the changes in temperature and unfortunate changes in glacier mass balance and glacier area. Coming back from data to information, as I mentioned at the beginning of my presentation, data is input to providing core services. And I would like with this to come back to the question that, what was, when you use natural capital and services concept, what kind of theoretical framework are you using? And I'm going to say that when what I was referring to services is the broader type of services of information being provided, in this case by institutions like the National Meteorological Services that support on an ongoing basis decisions at the societal level, whether it's about weather forecasts, whether it's about climate analysis, data, early warnings, and so on. So it wasn't that much as a concept as much as a generic approach to the provision of information to support decisions in the society related to where weather or climate are a factor in that decision process. So yes, that's in that context. So I took a look at the data from observations as input to the models that will generate the knowledge needed. And I just wanted to emphasize two types of information that are generally available from within the range of the services, one being early warnings or the warnings, and the other one, climate information on a regular basis, and going over not only understanding change as from a process point of view, but actually providing, and I have a slide on that, general information at relatively shorter timescales that would support various decisions. So here is a map of data on snow depth that has been ingested by the global models for numerical weather prediction. On 15th of January in 2020, and this is basically a duplication, I guess, of the map that I showed earlier, but this time focusing on the available observations, on snow depth. And as you can see, I mean, please ignore the different colors. These are the different formats in which data is present. So that's not, but this becomes very important for initializing the models and their latency. So the time between when the observation is taken and the observation is ingested is extremely important, because studies show that the accuracy of weather forecasts depends a lot on whether the observation is available, and snow plays an important role because of albedo in the quality of weather forecast and prediction. I mentioned about the climate function. So within the framework of WMO, and again, I want to emphasize the fact that this is establishing the foundation for regular updates, as opposed to the scientific research where the focus is on innovation, on new knowledge. The national services on meteorology, climatology, hydrology provide regular services. And from a climate perspective, most of them, here is a map that actually shows different centers that have regional responsibilities, and most areas are covered, but not so well with products that are relevant to mountain regions where, as far as snow and ice are concerned. But most of these centers provide long-range forecasts, provide some form of climate monitoring over 3-6 months, provide data services, provide training. They also provide some climate projections and prediction, and training and capacity development, including for experts from developing countries are typical services that are provided. And in your decisions, I encourage you to reach out, if you haven't done so, to your national services for specific information, because you may be surprised, one, by the richness of information available. Secondly, by the fact that there is a need to understand and hear from users to better tailor products to the needs. Here are this map and the next one. They really show, are here to show the interconnectedness at global level. No single institution can act independently. So at global level, the responsibilities, for example, this map is about nowcasting and weather forecasting. So everything that has to do up to 30 days. The information, at global level, so global models are being run, and then each national institution takes that input and downscales it to national level to higher geographical resolution, spatial resolution, and of course other centers for long range and climate forecasting. So this interconnectedness and the collaboration between the centers really enhance the value of the information that your national services and based on which you could establish a baseline for better understanding the changes within the immediate future and at the higher spatial resolution that would be of interest for your needs. I see that the time is 20 minutes to 6. I am just going to say a few things about kind of looking into the future. Any questions to this point? Okay. I see that there is a comment. You're all out of 8,000 meters above peaks in the world. 8 of them, including the highest peak in the world, Mount Everest, lies in Nepal, for your information. Yes, indeed. That was the reason, actually, I took the Nepal example for the presentation. I had the pleasure to work with Rosa Laura at this time when we prepared the High Mountain Summit, and that was the action that in the WMO context, with support from FAO and Mountain Partnership and other international organizations, we looked at what is missing, understanding that the people living in the mountain regions don't have access to adequate hydrometeorological and climate services of the same quality as those in lowlands. And there is a need to actually augment the series of products and information available to take into account this the specifics of mountain environments. So at the time when preparing the consultations for the summit, we actually looked at what is missing and realized that one of the key elements is that related to governance and interaction between the different organizations, institutions, and people, and more importantly, actually being aware of the players who are active in each region and recognizing the specificity of these regions. We recognize that, yes, there are fragmented environmental policies, that budgets are always insufficient, and it's difficult to develop and retain staff. It's difficult to develop and maintain observing networks, that the data management systems quite often are insufficient or incapable to deal with the diversity of institutions involved. But most importantly, we realized during the summit that what has been missing the most is the connection with users. Who is the information for has not been at the table as often as needed to actually co-design the products to meet the needs of those specific communities. And in that sense, we realized that we need a few things, whether it's understanding the needs and addressing the gaps, looking at how to address the gaps in terms of observations. And this is where we looked at the role that space-based observations excuse me, would play. The need to for interoperability and standardization. So a lot of technical elements, data platforms, but most importantly is about the service delivery mechanisms, is where to, how to reach and engage the users in co-designing the information system required. What is needed that would make a difference for you as users, that could be communicated to those who provide the information, such that would affect change. Here I have just a quick example of one system that is being deployed in many regions. It's a flash flood guidance system with coordination from WMO using, I'm going to say, information systems, models, and dissemination that is standardized but tailored to specific regions. And yeah, so it's part of the addressing, so using the international collaboration to address emerging needs and flash floods in many areas, including in mountain communities, are a major concern. And here I have as the one example how this is from Pico Bolivar in Venezuela, where the ability to track over time, it shows the significant, the stark changes in these regions, but it's actually in the context of understanding the circulation and the changes at continental level that provide the understanding of changes at local level and the link between regional and local level cannot be underestimated. I'm going to skip this, and I'm going to close with one statement that in the end, having access to sustained observations and sustained access to data are a necessity in the end for understanding climate change and monitoring extreme events, because in addition to understanding climate as a whole, change as a whole and over time, the understanding of the emerging extreme events and changes in their frequency and how those affect societies is something that can't be minimized, can't be forgotten. And the ability to address that today is not as strong as even the ability to monitor and report on change in the climate over time. So with this, I would like to thank you for the opportunity to speak today. And if there are any other questions, I'd be happy to answer.
Okay, first of all, I would like to thank very much Rodica for the presentation and sincerely for the pictures, because it reminded me some beautiful places where I made some expeditions. So thank again. And please, if there are questions, raise your hand virtually and they'll give you the word. And please, don't be shy. Even if we are online, you have to keep the spirit of IPROMO alive.
Danilo, while we wait for questions, allow me to thank Rodica for being available, being with us, and providing this very, very interesting lesson. It's great to partner with the World Meteorological Organization. I think this is a very nice result of this mountain partnership, the fact that it brings together United Nations organization, government, civil society, and we all share this common objective coming from different perspectives. So we all bring to the table different elements, and what WMO brings is really very valuable, and it's absolutely fantastic to have an ambassador like Rodica supporting this mountain cause. Thank you, Rodica.
Thank you for the opportunity. And if there are later on any questions, including on how to connect at national level with respective weather climate services, I'd be very happy to facilitate if I can. And yes, I would like to wish you a very successful course, recognizing that you have 2 weeks ahead of very interesting presentations and very diverse perspectives, and I'm sure I wish I had the opportunity to attend one of these courses in person. So I hope one day that will come. I'm sure it's a great group to very diverse experiences present here.
For sure. We all hope to go back to normal as soon as possible in a safe way. Okay.
Yes, definitely.
Danilo, over to you, and thank you to everyone for participating. This has been the first day. It has been, from my side, a lot of technological challenges, and my apologies, but it was great, and I look forward to continue interacting with all of you in the coming 2 weeks. Danilo, over to you, and thank you to all.
Okay, thank you, Zalaura. I don't know if also Michele, Professor Frepatz want to say something to end this first day.
I can just say many thanks to Rodica, all the participants. I really appreciate also all of this very nice white landscape, Me too, as a snow scientist, I'm very familiar with this landscape, and I think that, of course, the cryosphere could be very sensitive to climate change, so it's a very nice way to start with the IPROMO course, but I think we will move also at lower elevation, also in other place, not only snow and ice, but I think it's a good starting point. So thanks a lot, Rodica, and I'm really looking forward to meet you maybe in our mountain research station in the Monte Rosa Massif, where we have a mountain weather station at 2,900 meters above sea level. And so it's one of a few stations working. And for example, tomorrow, I think I have to go the morning up there to check, because we have an unexpected frozen time here. And so I expect some damage in our station up there. So it's very challenging to maintain such a weather station at such elevation. So I really appreciate also the way you explain these problems, the way we need to collect, in any case, such kind of data also at a very high elevation. So thanks again, and so thanks everybody. And Danilo, please.
Okay.
Thank you.
Thank you, Michele. And okay, just to close in, let's say, like the normal way, I will open all the microphones, so everybody will clap his hand or her hand to say thanks to Rodica, and then I will close the connection, and we'll see you tomorrow at the same time. Okay, ready?
Thank you.
So please clap your.
Thanks. Thank you.
See you tomorrow, everybody, and thank you very much.
Thank you, everybody.
Ciao.
Thank you.
Bye-bye. Ciao.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Bye.
Bye.